We're moving on to systems of equations and eventually inequalities. And what we do with these is eventually we solve two equations at one time. We solve for both variables. There's an x and a y variable in each of these. So we solve for x and y simultaneously. There's a few different strategies to use for them. And the first one we'll talk about is graphing. But before we can actually solve any of these, we need to understand what a system actually is. And it's nothing fancy at all. A linear system is simply formed by two equations. So x plus 2y equals 5 and 2x minus 3y equals 3 are both is one system of equations because we put the two equations together. Very important to understand this second bullet, that a solution of a linear system is an ordered pair x, y that satisfies each equation in the system. Okay, so it must be a true solution for both equations. So that means that point would lie on the graph of both equations. Consequently, if it's on the graph of both lines, that means it has to be the point of intersection where those two lines cross. So graphing is a good way to do this when the solutions are integers. It's difficult to estimate fractions or decimals or anything that we don't know as far as integers go. So we like to do these when we can have integer solutions. But let's take a look here at a couple things. We'll start simply by already having a graph given to us. We have the system 3x plus 2y equals 4 and negative x plus 3y equals negative 5. We have here, these seem to intersect at this point here, 2, negative 1. So we appear to intersect at 2, negative 1. What we do is now we have to check to see if it's true in both. So x is 2, so I have 3 times 2. Y is negative 1. And I need that to be 4. Well, 3 times 2 is 6. 2 times negative 1 is negative 2. 6 minus 2 is 4. That's true. So it is 2, negative 1 is a solution to that first equation. We try the same thing in this second one. So this would be negative 2 plus 3 times negative 1. And that needs to be negative 5. Now the reason it's negative 2 is we have the opposite of x. And our x was positive 2. The opposite is negative. So we have negative 2 minus 3 equals negative 5. That's negative 5 equals negative 5. So that's true as well. So yes, 2, negative 1 is a solution to the system of equations. Now, we need to graph one on our own here. So if we look, we have x plus y equals negative 2, and we have 2x minus 3y equals negative 9. So the first thing we want to do is write each equation in slope-intercept form. Well, for x plus y equals negative 2, all we have to do is subtract x from both sides. So we get y is equal to negative x minus 2. So that's one thing that we will graph. The second requires slightly more work, but still not too bad. 2x minus 3y equals negative 9. The first thing we'll do here is we'll subtract 2x from both sides. That'll leave us negative 3y equals negative 2x minus 9. And from here, we will divide everything by negative 3. I get y equals positive 2/3 x plus 3. So we have our two equations, and we're going to go ahead and graph them. I'll start with the blue one. My y-intercept is negative 2, so we plot that point. And from there, our slope is negative 1. So we go down 1, right 1. Down 1, right 1. Notice all these points. Sometimes it helps to draw them all out. It'll be nice when we see our point of intersection. We continue it back this direction as well. Okay, we will connect these with a solid line. For some reason the calibration's off here, but it should go through those dotted points there. We'll graph the red one here. Y-intercept is 3. 1, 2, 3. Slope is up 2, right 3. Up 2, right 3. Up 2, right 3. Obviously going that direction, we did not intersect the blue line at all. So let's carry that back the other direction. It looks like that's going to be my solution there. This point right here, because that blue line should go through there. So this point right here, let's actually draw that blue line like it's supposed to be so we can see it. This point right here, and that is negative 3, positive 1, is the solution to our system because that's the point where the two lines cross. So you want to write each equation in slope-intercept form, then graph them, and then identify that point where the two lines do actually cross. That's all we have. We'll continue with those tomorrow. Lots of practice coming on systems of equations.